So with our first NTI day of notes, this isn't anything new to you guys. You all are accustomed to this, so I don't really have a whole lot to introduce to you as far as how this is going to go. There are going to be a couple of changes with our class specifically. I'm only doing this with your all's class. Your assignment due dates are going to kind of be left up to you. That's not to say that you don't get to avoid doing homework completely, but what I would like for you to do is not get stressed out over the sheer amount of work that you're going to probably have over the next couple of weeks. So with that being said, just try to work on it a little bit at a time. Don't stress over due dates. At this point, the only thing that I have a firm due date on was 2/2, and that was on Friday. Everything from this point forward, get it to me when you can, but don't let it build up. So it's going to you guys are going to have to be a little bit responsible for it and figure out your own methods on how you want to complete the homework. But when you submit it to me, I'll accept it. No penalties for late assignments. So keep that in mind. Make sure that you are at least being somewhat responsible for it, though. But again, like I said, don't stress over due dates. Just get it done. So what we're going to start talking about right now are normally distributed variables. And this is kind of where everything starts to come together from this point forward. We're kind of tying things in, and we're looking at how it all relates to one another and what some statistical analyses might end up looking like. So the first thing obviously is going to be the normal curve. What we first start out with here, you can see in the middle of the screen, we're talking about density curves. A density curve is always above the horizontal axis, and the total area under that density curve is always equal to 1. So we talked about probabilities before. The probability of any variable always adds up to 1. The area under a density curve is always also going to add up to be 1. I'm not going to read through everything with this for you guys. You're perfectly capable of reading, but you can see when we talk about density curves, here again another note there at the middle of the screen. For a variable with a density curve, the percentage of all possible observations of the variable that lie within any specified range equals, at least approximately, the corresponding area under that curve. Calculus would be very beneficial here to find area under a curve, but we're not using calculus right now, so we will use other methods to come up with these areas. Let's see. We'll scroll on down. So I know you guys have heard of normal curves. You've heard of a bell curve. A normal curve is always centered about the mean of the set of data, and then you have standard deviations. 3 standard deviations typically to the right, and 3 standard deviations to the left, and that generates your curve. It is bell-shaped. Here on your screen you can kind of see a normal curve. This is the standard normal curve because it has a mean of 0 and standard deviation of 1, and that will be something we're going to talk about too later on here. So a variable is said to be normally distributed if it has a normal distribution and the distribution is approximately the shape of the normal curve. There can be a little bit of variation to that. Obviously, anything too extreme, we're going to say that it is not normal, and we won't discuss that as being a normal curve. The things that I want to look at here, example 1. So I'm really not going to be writing anything on the screen here, so this is going to be very heavy with Google Sheets. Example 2, I'm going to go through it in these notes. I will create a separate video going into detail about how I did what I'm going to do with that set of data. But for example 1, we're given these frequencies of heights of female students at a Midwestern college. It says that the mean height of the students is 64.4 inches. And my pen is not writing for some reason. There we go. 64.4 inches. Standard deviation is 2.4 inches. And we are given the frequency distributions and the relative frequency as well. So you can see that here in this table. For part A, it says show that the variable height is approximately normally distributed for this population. So we're going to Google Sheets to look at this. And apparently I closed it. I had everything ready and I closed it. So let's try this. Okay, there is our table that we saw on the notes. What I would like to do now is to show that the height is normally distributed. So I'm going to highlight height. You can highlight frequency or relative frequency. Again, either one will give you the same shape. So I'm going to highlight relative frequency. And then I'm going to click on Insert Chart. And it should bring up a column chart. Oh, it brought up a scatter chart. Let's go to a column chart. And there is our distribution. And you can see that definitely does look approximately normal. It's very symmetric, especially around, looks like the 64 to under 65 is the midpoint. And our mean, I believe, was 64.4 inches, so that is pretty accurate. That's all you have to do to show that it is normally distributed. For part B, it says identify the normal curve associated for that population. So with Google Sheets, that's easy to do. We can go to, if you're using a column chart, when we go to the next example, things get a little more complicated. But with the chart editor here, if you go to Customize and then you click on Series, scroll down and you can see there's a box for trend line. So we want to check trend line, and then under the type, change that to a moving average. And now you can see that curve that popped up, and that does appear to be an approximately normal curve for this particular set of data. So we've shown it through the column chart, and we've shown it through the curve itself that this set of data does seem to be approximately normal. And then part C just says discuss the relationship between the percentage of female students whose heights lie within a specified range and the corresponding area under the associated normal curve. So here, looking at the chart, if I pull it back up here on Sheets, let's look at 66 to under 67. So that's this third column right here to the right of the mean. And under 66 to under 67, the relative frequency is 0.1100. So what we can say then about that particular bar is if that were a shaded region completely under that curve, it's actually 11%. That's 11% of the values lie in that curve, in that shaded area of the curve. And you can do that with any of the relative frequencies. So 63 to under 64 is 14.8%. If that was a shaded region, we just took the normal curve, we got rid of the column chart, 14.8% of the curve would be shaded to represent 63 to under 64 inches. When we go to standardizing a normally distributed variable, this is something we've done before. We've calculated z values. This is going to become much more important as we progress through this section on normal curves and normal values. The z value is, just a little reminder right here, z is equal to x minus mu divided by sigma. So it's x minus your mean divided by your standard deviation, and that gives you the standardized value. Remember, all your standardized values are going to be between -3 and 3 pretty much. You have a rare few that are less than -3 and a rare few that are greater than +3. But with the standard normal curve, mean is 0, standard deviations are 1, and so we expect all of our data to, at least 99% of the data, to be between -3 and 3 standard deviations of the mean. This just is an example. It shows just the normal curve of a given set of data, and this shows the standard normal curve. The areas are equal when we standardize a variable. So if we took the value, say, from the heights there a minute ago, and I standardized that, my mean would be 0, and my standard deviations would all lie between -3 and 3. Whereas in the the example that we had before, the mean was 64.4, and the standard deviation was, I think, 2.4 inches. So when we standardize a value, it allows us to compare two different sets of data just to see what the true trend is between those two sets of data. This is where things are going to get a little confusing. Simulating a normal distribution. I'm going to do this example to keep this video short. I will make a separate video later on to show how to do this in Google Sheets. So example 2, you have gestation periods of humans are normally distributed with a mean of 266 days and a standard deviation of 16 days. This says to simulate 1,000 human gestation periods, obtain a histogram of the simulated data, and interpret the results. So what we want to do, if I can pull it up here, is I've already done the simulation in this column A. You can see the equation that I used. It's equal NORMINV, rand array, and then I have my mean and my standard deviation, and I just hit enter, and I drug that down through 1,000 cells to simulate the data. So I have my 1,000 simulations going down the column A here. I've calculated the mean, median, standard deviation. You don't necessarily have to always do that, but we do want to have the mean and the standard deviation of our simulation. You can see this is approximately equal to what we expected when we were given the information in the question itself. The mean was 266 days, standard deviation was 16 days, and that's fairly close with what we had with the simulation. When you simulate your own data, it may be a little bit different. We've discussed simulations before. So the 4 columns here, or the 5 columns rather, from F through J, this is where things are going to be a little tricky as far as you guys needing to practice this and work with Google Sheets to do this. It took me a while to figure it out as well. So what I've done, you can see I've labeled these 5 columns. I have one that's called bins. And if you remember, we talked about histograms. Our bins were the width of the data that we were looking at. So in this case, I have it set at 150 days to 152 to 154. So my bin size is 2 days. Then I have this normal distribution formula. That's this column. And there's the equation up there in the equation bar. It's equal to norm dist. And then I have F2, which is the 150. And then it's going to be the mean, standard deviation, and then we're going to type in the word false because we do not want it to do a cumulative value. And then you would drag that all the way down. And I've gone all the way down to 380 days because that's where it starts to get closer to 0. I'll explain all this in a separate video. Then I have 2 columns. I have one called histogram and I have another one called histogram 2. And those values are exactly the same, but we need those 2 columns to generate an appropriate chart that has not only our histogram, but also has a normal curve overlaid on that histogram. So without getting into too much detail about the simulation itself and the values that we've computed, we're going to show this simulation to be approximately normal. We've already shown that the mean and standard deviation is roughly equivalent to what we would have expected. So to do the chart that the correct chart with the histogram and the normal curve, I want to select all the values here under bins, and then I also want to select these other 3 columns on the end. I want to ignore that normal distribution formula. So I highlight those, and then I'm going to go to Insert Chart, and the chart that I want is a combo chart. Right here under Lines, it's the 3rd one over on my screen, is Combo Chart, and I have my values there. So now I had to make myself some notes, so I'm going to refer back to my notes here a little bit to make sure that I don't mislead you guys on how to do this. So I think I missed one here. Yeah. Okay. So we have we're going to scroll down and make sure that everything's checked off. Use column F as labels. So my last column, or my column for my bins, that's going to be my labels. And you can choose to remove the legend if you want to. I'm probably going to just take it off just to clean things up a little bit. I don't need that. I'm probably going to take the title off as well. But for right now, that's all we need. I want to also, let's see, go to chart axis and titles. That's not it. Series. No. I'm missing something here. Chart style. There we go. Okay, under chart style, I apologize. Very top, chart style. Click on smooth so that it will smooth these lines out. A minute ago, the lines were very jagged. So we want to smooth those lines out. Then we want to, all the horizontal, vertical axis, everything looks okay there. So we don't need to change anything on that. And in the customization menu, we want to go to series, and let's select the normal distribution series, and we're going to change that from columns to line. And so there's our normal curve, and so we're starting to make this data look a little bit more presentable. Again, let me refer back to my notes. Now we want to check the histogram series, the first one, and we want to change that to columns. And then we want to take histogram 2 and we want to change that to stepped area. Just for clarity's sake, I'm going to change that color to red as well. Change line thickness to 1. These are things you can play with. You don't have to do these values like I'm doing. I'm just trying to make it all look similar. All right, looks better. So we can see our normal curve and we can see our histogram with the density. And that is actually the end of the chart. We've got our, let me make sure I didn't forget anything. Yeah, okay. So we do have our normal curve overlaid with the distribution of the frequencies that appeared in our simulation. I'll make this chart a little bit bigger so you can see it. I want to move this around. There we go. I could have probably cut off some of the values between 150 to 198 and from 330 out to 380, but we're just going to leave it like this. You're going to have to, when I make the second video that shows you how to do this in more detail, you'll understand that this does require you to play with it a little bit. But this does show the distribution. You can see the normal curve, how the data kind of fits that. So we can say that this simulation does indicate an approximately normally distributed set of data. And that actually should be the end of this set of notes. So this is, yeah, homework problems. Just refer back to some of the things that I glossed over. Make sure you read through all the notes completely to make sure you have everything that you need. I hit the high points. Try to keep these videos short. I know you guys are going to be inundated with the videos and work over the next couple of weeks. So again, any questions, you know how to reach me. Please feel free to bother me anytime. Make sure you work on the homework at your leisure. Don't avoid it, but try to work on it. No due dates. Just get it done when you can and get it submitted to me. I hope everybody is doing okay, and I will talk to you later.